Okay, today we start Diborane. Diborane. So yesterday we have finished up to boric acid. Today's topic is Diborane. So Diborane preparation, properties, structure and uses. So Diborane is a colorless gas. So this gas is filled in cylinder. Okay. So it is a colorless compound, diamagnetic compound. Diamagnetic compound means which is attracted by magnetic field with a low thermal stability. So with a sweet smell. Okay. So extremely toxic gas. Diborane is extremely toxic gas and extremely reactive gas. Okay. So this gas is manufactured by the Chinese companies. Okay. Right. Preparation of diborane. So diborane prepared from boron or boron compound. Boron trifluoride, sodium borohydride, magnesium boride. From boron compound, we can prepare diborane. So there are three methods are given here. Okay. So boron trifluoride reacts with sodium hydride at the temperature of 450. Diborane is subtype. Okay, along with a sodium fluoride. So 2 moles of boron trifluoride, 6 moles of sodium hydride, which gives 1 mole of diborane and 6 moles of sodium fluoride. So this one is industrial preparation of diborane. Industrial preparation of diborane. So if you want to prepare small amount, then you can use sodium borohydride. So NaBH4. The compound is called sodium borohydride. BF3, the compound is called boron trifluoride. So this one is sodium borohydride. This sodium borohydride dissolve in diglycine. So diglycine is polyether. Okay, diglycol methyl ether. Diglycol methyl ether. So it is used as organic solvent. This organic solvent which dissolves sodium borohydride. This solution is treated with iodine, which gives diborane and 2 moles of sodium iodide and 1 mole of hydrogen. Okay, so if you want to prepare small quantity, you can use this method. So the second method. The third method is from magnesium boride. So Mg3B2. Why? Boron valency 3, magnesium valency 2. So you have to interchange the valency, you'll get Mg3B2. So this magnesium boride dissolve in hydrochloric acid. So which gives mixture of borane compound. Mixture of borane compound. So borane compound means what? Boron hydride compounds are called as borane compound. So this also, okay, boron hydride, this is also boron hydride. Okay, but the ratio is different. The ratio is different. So magnesium boride reacts with hydrochloric acid, which gives mixture of borane compounds. So 2 moles of magnesium boride and 12 moles of hydrochloric acid, which gives 6 moles of magnesium chloride and 1 mole of tetraborane. Tetraborane 10. Okay, along with the hydrogen. This tetraborane 10 reacts with the hydrogen, which gives diborane. Okay, so 3 method of preparation of diborane. One from boron trifluoride, the second from sodium borohydride, the third from magnesium boride. The next one is properties of diborane. So action of heat, action of water, action of alkali solution, action of air, action of methyl alcohol, action of alkene and alkyne, action of metal hydride, action of ammonia. Okay, so first we can see action of heat. Okay, so diborane at a high temperature, which gives the higher number of borane compounds along with the hydrogen. Okay, so the product depends on the ratio of reactant and the condition. Okay, so depends on that, we are getting different borane compounds. So first you can see that the 5 moles of diborane at the temperature of 388 Kelvin. So which gives pentaborane 11. So pentaborane which represent 5 boron atom, 11 which represent 11 hydrogen. Okay, so according to nomenclature rule, okay, B5H11, okay, the name is written as pentaborane 11 along with the hydrogen. Then you have to change the, okay, the quantity of reactant. Only 2 moles of diborane between the temperature 198 to 373 Kelvin, which gives tetraborane 10. Tetraborane 10. Okay, so tetra represent 4 boron and 10 represent 10 hydrogen. Again, if we take 5 moles of diborane, now you have to change the temperature. Instead of 388 Kelvin, 373 Kelvin, the product is decaborane 14. Decaborane 14. So deca means 10 boron and 14 hydrogen. Okay, so the product is called decaborane 14. So this reaction takes place in sealed tube. The same 5 moles of diborane, but here the temperature is 473 to 523 Kelvin. The product is pentaborane 9. So here 5 moles of diborane, here also 5 moles of diborane. Which one is different? If you take 388 Kelvin, the product is pentaborane 11. 473 to 523 Kelvin, the product is pentaborane 9. So here only 9 hydrogen, so the name is 9. Pentaborane 9. Then if we take 10 moles of diborane at the temperature of 523 Kelvin, you are getting the mixture of pentaborane 9 and pentaborane 10 along with the hydrogen. Okay, so from the product you can see that, okay, different quantity of reactant with different temperature, you will get different type of borane. Okay, so diborane at the red hot highest temperature, which decomposes into boron and hydrogen. Okay, so at low temperature, which gives, okay, different type of borane, but at high temperature, which decomposes into boron and hydrogen. Okay, so action of heat means you have to write the formation of different boron, that is borane. The next one is action of water. Diborane dissolved in water, which gives boric acid. So boric acid H3BO3. Okay, the oxy acids of boron. Okay, right. So if you mix sodium hydroxide, then the solution become alkali. Okay, so diborane reacts with the alkali solution, which gives sodium metaborate. So diborane, 1 mole of diborane reacts with 2 moles of sodium hydroxide, which dissolve in 2 moles of water, which gives sodium metaborate. That is 2 moles of sodium metaborate. The next one is action of air. So in the pure form, okay, there is no reaction at room temperature. Pure form. Okay, if you take pure diborane at room temperature, no burning reaction. If you want to carry out burning reaction, the diborane must contain impurities. Then only the combustion reaction takes place. So diborane, okay, contain little amount of impurities which undergoes combustion with the oxygen. So which gives boron trioxide and water. So this reaction is extremely exothermic. So delta H value negative. So the reaction is exothermic reaction. That means a lot of heat energy is released. So diborane is used as fuel. The next one is action of methyl alcohol. So diborane reacts with methyl alcohol, which gives trimethyl borate. Okay. So already we have seen, okay, ethyl borate test. In that test, we have taken ethyl alcohol, but here we have taken methyl alcohol. So diborane, 1 mole of diborane reacts with 6 moles of methyl alcohol, which gives trimethyl borate. Okay, so 6 hydrogen replaced by methoxy group. So CH3 means methyl group, CH3O means methoxy group. So 6 hydrogen replaced by methoxy group. So the product is BOHOCH3 thrice. The compound is called trimethyl borate, like triethyl borate. Okay, right. The next one is action of alkaline and alkyne. So alkene and alkyne. Okay, alkene and alkyne are organic compound. Okay, so diborane reacts with the organic compound. So this reaction is called as hydroboration. Hydroboration. So hydroboration means, okay, diborane addition with a alkene or alkyne in the presence of ether solvent at room temperature. This reaction is called hydroboration. So what is hydroboration means? You have tried this one. That is addition of diborane with the alkene or alkyne. So which gives trialkyl borane. Trialkyl borane. So this reaction used in synthetic organic chemistry, especially for the anti-margonico addition. So what is mean by margonico addition? The any unsaturated organic compound, okay, addition with a, okay, addendum. The negative part of addendum attached with the carbon containing fewer number of hydrogen is called margonico rule. But if you want to violate the rule, okay, the addition reaction carry out in the presence of diborane. Okay, so in the absence of diborane, you will get regular addition product. The same addition reaction take place in the presence of diborane. The anti-margonico product is obtained. So first, okay, the unsaturated compound, okay, reacts with the diborane instead of addendum. So first step, the unsaturated compound alkene or alkyne reacts with the diborane, which gives trialkyl borane. Then this trialkyl borane addition with a, okay, addendum, which gives anti-margonico product. So this reaction is called hydroboration. So especially to get anti-margonico product. The next one is a reaction with a, okay, ionic hydride. Reaction with a ionic hydride. So diborane reacts with a lithium hydride in the presence of ether. So 1 mole of diborane and 2 moles of lithium hydride in the presence of ether, which gives lithium borohydride. Okay, so lithium borohydride is a very important reducing agent used in organic chemistry. So like that, sodium borohydride. Okay, so this is also very important or common reducing agent used in organic reaction. Okay, so diborane reacts with the sodium hydride in the presence of diglycine. So diglycine means diglycol methyl ether. So gly represent glycol, M represent methyl, E represent ether. So diglycol methyl ether as a, okay, organic solvent. So it is a polyether compound. Polyether compound. So this polyether compound used as solvent in this reaction. So diborane reacts with a sodium hydride in the presence of diglycine, which gives sodium borohydride. So lithium borohydride and sodium borohydride, both are important reducing agent used in organic reaction. Okay. So next one is the reaction with the ammonia. So this reaction temperature dependent. Okay. So 3 moles of diborane reacts with 6 moles of ammonia. Okay, at the temperature of minus 153 Kelvin. That means at low temperature. So low temperature gives diborane diammonate. So it is an addition molecule or complex molecule. Okay, so 3B2H6 2NH3. This one is addition product. Or the modification take place and gives complex molecule. Okay, so BH2 NH3 twice plus BH4 minus. So this one is complex compound. Okay, at low temperature, which gives diborane diammonate. If you increase the temperature, that means at high temperature in closed vessel. So instead of addition reaction, okay, the cyclic reaction take place, which gives borosol, or you can say borosine. This compound is called as inorganic benzene because this structure is look like a benzene. So the compound is called inorganic benzene. Okay, inorganic benzene. So very important. So how will you prepare inorganic benzene? So you have to write this one. So at low temperature, there is no formation of inorganic benzene. But at high temperature, the formation of inorganic benzene is obtained. Okay. So in this structure, you can see the nitrogen and the boron are arranged in the alternative manner. So nitrogen, boron, nitrogen, boron, nitrogen, boron. So nitrogen, boron, both contain hydrogen. So here NH, here BH. So B3, N3, H6. What is the formula of borosine? B3, N3, H6. So borosine, or you can say borosol. So diborane reacts with ammonia at a high temperature, which gives borosol or borosine. Okay, so very important reaction. So after chemical properties, the next one is structure of diborane. So structure of diborane is very important question. 3-mark question. So structure of diborane. Okay. So this structure having different type of bond. Different type of bond. So first you can see that this structure having 2 unit of BH2. So this one BH2, this another BH2. So BH2, BH2. These 2 BH2 unit, linked through hydrogen bond. These 2 unit linked through hydrogen bond. So this bond is called bridge bond. This bridge hydrogen bond. Okay. So we can discuss in detail. Okay. So if you want to explain structure, you should know hybridization. Okay. So methane, what is the hybridization? sp3 hybridization. So in methane, carbon, undergoes hybridization. So 1 s orbital, 3 p orbital mixed together to give sp3 hybridized orbital. So sp3 hybridized orbital having 4 equivalent orbital, hybridized orbital with 1 electron. Okay. Here boron also the same hybridization. Okay. But here the somewhat different concept. Boron 1 s orbital and 3 p orbital mixed together form 4 equivalent hybridized orbital with 3 electrons. So in methane, carbon follows sp3 hybridization. 4 equivalent orbital with 4 electron. But here 4 equivalent orbital with 3 electron. Because boron form electron deficient compound. Okay, so which is having only 3 electron. Okay, so here out of 4 equivalent orbital, 2 equivalent orbital of boron with 1 electron, that is half filled orbital. So 1 electron means half filled, 2 electron means filled orbital. So here only 1 orbital, only 1 electron. So the sp3 hybridized orbital with 1 electron. Okay, 2 sp3 hybridized orbital called as half filled orbital. Okay, so overlap with a half filled orbital of hydrogen. So which gives 2 boron hydrogen bond. So here 2 boron hydrogen bond, here 2 boron hydrogen bond. Okay, so 2 electron, 4 electron, 6 electron, 8 electron. So total number of valence electron 12. Out of 12, 8 electron involved in the boron hydrogen bond formation. So 2 electron, 2 electron, 2 electron, 2 electron, totally 8 electron. So remaining how many electron? Remaining only 4 electron. Remaining only 4 electron. Okay, so this 4 electron involved in the bridge bond formation, which involved in the bridge bond formation. Okay, so how this bridge bond formation take place? Okay, so very simple concept. So out of 4 equivalent, 2 equivalent hybridized orbital of boron involved in the normal covalent bond. So this one is normal covalent bond. The rest of the equivalent orbital, which one? Half filled sp3 hybridized orbital and one empty hybridized orbital. So likewise, in this boron also half filled hybridized orbital and empty hybridized orbital. Okay, so in the bridge bond formation, one half filled orbital of hybridized orbital of boron, empty hybridized orbital of another boron, and a half filled orbital of hydrogen. These 3 orbitals overlap together, form boron hydrogen boron bond. So how many boron hydrogen boron bond? Okay, 2 boron hydrogen boron bond. So boron hydrogen boron bond, boron hydrogen boron bond. So this bond is called, okay, 3 center 2 electron bond. Center 1, center 2, center 3. Okay, 3 center, only 2 electron is involved. So the bond is called 3 center 2 electron bond. So how many 3 center 2 electron? Only 2. So this one 3 center 2 electron and this 3 center 2 electron. So totally 2 bridge bond, or you can say that 3 center 2 electron bond. What is the name of this bond? So this bond is called 2 center 2 electron. This one center, this another center. So this called as, okay, 2 center 2 electron. 2 center 2 electron. But this one is called as 3 center 2 electron. So how many 2 center 2 electron? 1, 2, 3, 4. So 4, okay, 2 center 2 electron bond, or you can say 4 BH bond. So this one is normal covalent bond. So how many electron involved? 8 electron. Okay, so remaining 4 electron involved in the bridge hydrogen bond. Bridge hydrogen bond, or you can say 3 center 2 electron bond. Okay, so what type of hybridization take place in boron? Okay, sp3 hybridization take place in boron. Okay, the last one is uses of diborane. So diborane is used as high energy fuel for propellant because diborane gas is thermally less stable. Okay, which undergoes combustion. Okay, so it is used as a reducing agent in organic chemistry. Okay, so lithium borohydride, sodium borohydride, so good reducing agent. So it is also used in welding torch. So instead of acetylene gas, we can use diborane gas for welding purpose. Okay, so uses of diborane. So today we finished diborane compound. So diborane is one of the compound of boron. So in previous class we finished, okay, boric acid and borax. Okay, so this is the third compound. This is the third compound, diborane. So diborane is nothing but boron hydride compound. Diborane is nothing but, okay, boron hydride compound. Okay, so preparation, properties, structure and uses. So this one is colorless gas with a, okay, sweet smell. It is a highly toxic in nature. So in the preparation, it can be prepared from boron trifluoride, sodium borohydride, magnesium boride. So chemical properties, okay, we can see action of heat, action of water, action of alkali, action of air, action of methyl alcohol, action of alkene and alkyne, that is hydroboration reaction. Okay, so action of metal hydride and action of ammonia, or you can say that preparation of borosine or preparation of inorganic benzene. This one is action of heat, This one is action of water. This one is action of alkali solution. This one is action of air, that is combustion reaction. That's why it is used as fuel. With the release of enormous amount of heat energy. Action of methyl alcohol. Hydroboration, very important organic reaction. To form anti-margonico product. To prepare anti-margonico product. Preparation of borohydride, good reducing agent. So preparation of borosine, at high temperature. Structure. So how many type of bond? Only 2 type of bond. What type of bond? Boron hydrogen, one type. Boron hydrogen boron, another type. So 2 center 2 electron bond and 3 center 2 electron bond. So what hybridization in diborane? sp3 hybridization. So how many electron in hybridized orbital? Only 3 electron with 1 empty orbital. So usually 4 equivalent orbital, hybridized orbital with 4 electron. But in boron, only 3 electron with 1 empty orbital, which leads to bridge bond, that is banana bond. Then uses. Right. Thank you. Thank you, students. I hope you understand the concept. Keep learning. Stay reactive.